Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out the practice problems from the second full-length practice test on my website. In case this is your first time finding my YouTube channel, I want to mention that I recently created a small website called ASVABApp.com, and there you can take 3 short practice tests as well as 2 long practice tests. And all of them, once you finish them, give you a rough estimate of your AFQT score. In the event you don't want to go to this website to take this practice test, you're more than welcome to just watch this video and work on the problems as I work on them. In that case, I'd recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. Just as a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB. So as you take this practice test either on the website or here on YouTube, try not to make use of any of those resources. Finally, I want to mention that in the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamp, of course, there's going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point you feel as if you need more help with a certain topic, just check the description of this video, and there you'll find those additional resources. So all that being said, let's go ahead and get started with today's video. All right, so this first question says, simplify the expression we have in parentheses 4 times 12 divided by, in parentheses, 5 plus 6 plus 1 plus 72 plus, in parentheses, 2 times 1 plus 2 cubed. Okay, so for this problem, we're going to have to make use of the order of operations to figure out how we work this one out. And the order of operations, in case you haven't seen those in a while, are best remembered by the acronym PEMDAS, or Please Excuse My Dear Aunt Sally. As long as we follow these order of operations, we should be able to work this problem out pretty easily. And the P, in case you're wondering, in PEMDAS stands for parentheses. That means you work out what's in parentheses first. Then you move on to E, or exponents. Then you do multiplication and division as they appear in the expression from left to right. That is to say, they're equals. So if you have division before multiplication, you do the division first. Likewise, addition and subtraction are equals as well. So you work them out as they appear in the expression from left to right. Okay, so with that in mind, let's go ahead and just copy down this expression. Get on the ASVAB. You're going to have scratch paper, so for problems that are going to take a little bit of work to do, I always recommend that you copy them down right away. So we have 4 times 12 in parentheses divided by 5 plus 6 plus 1 plus 72. And this is where most people make a mistake that gets that would prompt them to get the question wrong. So take your time as you do this. Then we have 2 times 1 plus 2 cubed. Okay. So according to the order of operations here, we do what's in parentheses first. And as you can see, we have 3 sets of parentheses, one here, and one here. So let's go ahead and work on these one by one. In this first set of parentheses, we only have one operation, notably multiplication. So we're going to go ahead and work this one out. 4 times 12, you should be able to do in your head, that's going to be 48. Okay. In this set of parentheses, we just have addition. So we can just do this one very quickly. This is the same as 6 plus 6, which is going to be 12. Again, just copy down that plus 72. And in our final set of parentheses, we now have multiplication and addition. Well, according to the order of operations, multiplication, as you can see, comes before addition. So we're going to do this 2 times 1 first. So this becomes 2 times 1, which is 2, and then plus 2 cubed. Okay? So let me just copy this down so we can keep working on this one. We have 2 plus 2 cubed. Again, we're still working on this set of parentheses here. So let's just copy everything down. And I'm not going to skip any steps because I don't know who's watching this video. Some people could solve this very quickly. But again, we're going to take this step by step. So let's finally work out what's in parentheses here. 2 plus 2 is 4. So this becomes 4 cubed. And as you can see, we started with 3 sets of parentheses and we got rid of all the parentheses. Okay? So let's look through our expression one more time. And as you can see, we have division, addition, addition, and an exponent. According to the order of operations, we're going to do the exponent before anything else. So let's scroll down a little bit. Just going to copy everything down. 48 divided by 12 plus 72. And then we want to work out this 4 to the third. Well, 4 to the third is the same as 4 times 4 times 4. 4 times 4 is 16. 16 times 4, if you can't do it in your head, we'll do it off to the side. This is 16 times 4. 6 times 4 is 24, so we're going to drop down a 4 and carry a 2. 1 times 4 is 4, plus 2 is 6. So this becomes plus 64. Okay. And let me scroll back up to our order of operations so we can see them. We've now taken care of our exponents. Now we're working on the rest of the order of operations. And as you can see, we have division here, addition, and addition. Well, division comes before addition, so we're going to take care of that real quick. So 48 divided by 12, that's going to be 4, of course. So we have plus 72 plus 64. Now this is just simple arithmetic here. We're doing 4 plus 72 plus 64. Again, we could just add these all together vertically if we want. We have 72, 64, and 4. 4 plus 4 is 8 plus 2 is 10, so we're going to drop down a 0 and carry a 1. 7 plus 6 is 13 plus 1 is 14. So we can see that this reduces to 140, which is answer choice A. Okay, so that is the order of operations. You absolutely have to know these for the ASVAB. Again, please excuse my dear Aunt Sally, or PEMDAS. As long as you remember the order of operations and more importantly how to use them, you should be able to get any question that looks like this correct on the ASVAB. All right, number 2 says if x equals 3, y equals -4, and z equals 2, determine the value of the following. We have 5 times x minus z over x times y. So this one, as you might expect, is pretty simple. All we have to do is substitute these values into the expression accordingly, and then simplify it if possible. So I'm going to start, not surprisingly, by copying down this expression off to the right here. And you want to get it in a habit of copying down the problems you see in this video on your own scratch paper, because you're absolutely going to have to do that on the ASVAB. So this is 5x minus z over x times y. And according to the problem, we know x equals 3, y equals -4, and z equals 2. So let's plug those in. We have 5 times x. Well, x is 3, so this becomes 5 times 3. And before you start working this out, you want to plug all the values in. So this is 5 times 3 minus z, which is 2, so it's just minus 2 there, over x. X is 3 times y. Y is -4. All right, let's start reducing this. 5 times 3 is 15 minus 2. 3 times -4, well, positive times a negative is a negative. 3 times 4, as we should know, is 12. Okay, let's simplify this numerator and then we'll be done here. 15 minus 2 is 13 over -12. So this is -13 over 12, which is answer choice D in this case. Okay, very simple problem. Again, just take those values, plug them in, and then simplify. All right, number 3 says 45% of what number is 9? So one of the most popular videos on my channel is a video called Percents. And I think that video is popular because I tell you how to translate word problems involving percents into algebraic expressions, and it's not that difficult. So right here, we have 45%. Well, as far as percents go, they're always going to be written in decimal form. So this is 0.45. Of in math means multiplication. What number? Usually, you can represent an unknown value with an n or an x. I'm going to call this what number n is 9. Well, is equal 9. Okay, so just like that, I translated this word problem into an algebraic expression. And let me rewrite it down here. This is 0.45 times n, which is the same as 0.45n equals 9. Okay, so at this point, all we have to do is solve for n to figure out what the answer is going to be. So I'm going to divide both sides by 0.45. This is going to cross out here, leaving us with just n over here. Now this is where some people might get tripped up as well. This fraction can be read as long division. So this can be read as 9 divided by 0.45, in which case we're going to do it like this. 9 divided by 0.45. And as you can see, we're doing long division that has a decimal outside this division bracket. Whenever that's the case, you have to shift your decimal such that you eliminate the decimal outside the division bracket. And let me show you how to do that real quick. It's not as hard as you think. Again, technically 9 has a decimal right there, and it has as many zeros as we need. So I'm just going to put 2 zeros right there. And to get rid of this decimal in 0.45, I'm going to shift it 2 times to the right. That's going to make it 45. Now, in order to preserve proportionality, I also have to shift this decimal in 9 2 times to the right as well. So instead of being 9, this is going to be 900. So we've eliminated that decimal outside the division bracket, which is going to enable us to do this math pretty easily. And the question is, how many times does 45 go into 9? It doesn't. How many times does 45 go into 90? Well, that's 2 times, given that 45 times 2 is 90. That said, we want to figure out how many times 45 goes into 900. If I tack on an extra 0 there, this will be 45 times 20, which will be 900 evenly with no remainder. And therefore, we know n in this case is 20, which is B. Okay, you do have to get proficient at doing long division with decimals in order to be successful on the ASVAB. And likewise, you have to get proficient at converting these very simple problems involving percents into algebraic expressions. Again, I have videos for long division as well as percents and decimals on my channel. If that's something with which you struggle, just go ahead and check those videos out. They're actually pretty popular. All right, number 4 says, if 5 2/3 divided by 1/4 is C, then the value of C is between which of the following pairs of numbers? We have 5 2/3 divided by 1/4 equal to C. That is to say, we're dividing a mixed number by a fraction. Well, that's not that easy to do. We know how to divide, or should know how to divide, two fractions. So the very first thing I'm going to do in this problem is take this 5 2/3, which is a mixed number, and convert it to an improper fraction, or just a fraction. So to do that, I'm going to do 5 times 3, which is 15, plus 2, which is 17 over 3. And again, this is divided by 1/4 equals C. Now that we have two fractions that we're dividing, we can follow this algorithm: keep, change, flip. This K refers to this first fraction. It says keep it the same, so I'm just going to copy it down as is. This is 17 over 3. This change refers to this division sign. You're going to change it from division to multiplication. And this f, or flip, refers to the second fraction. And instead of being 1 over 4, you're going to flip it to be 4 over 1. And now, all we do is have to multiply these two together, and we'll be done. So when you multiply fractions, you multiply straight across. So you do 17 times 4 and 3 times 1. Okay, so again, I'm going to write it all out in case this is your first time multiplying fractions in a long time. So this is 17 times 4 over 3 times 1 equaling C. 3 times 1 is pretty easy to do. Anything times 1 is itself. So 3 times 1 is just 3. 17 times 4, I'm going to work it off to the side so I don't make any mistakes. This is 17 times 4. 7 times 4 is 28, so we're going to drop down an 8 and carry a 2. 1 times 4 is 4 plus 2 is 6. So this is 68 divided by 3 equals C. All right, so again, to figure out what C is, I'm now going to perform this long division. As I just mentioned, this is 68 divided by 3. 3 goes into 6 2 times without going over. 3 times 2 is 6. 6 minus 6 is nothing, but we have to drop down this 8. 3 goes into 8 2 times without going over. 3 times 2 is 6. 8 minus 6 is 2. And if we want, we can add a decimal here and a couple 0 placeholders. Again, now we can drop down one of these zeros and bring this decimal up right here. And the question becomes, how many times does 3 go into 20? Well, 3 goes into 20 6 times without going over. And we could proceed if we wanted to, but we know what the value of C is. C is approximately 22.6, okay? So, in other words, C is going to be between 22 and 23. So that's that one. Again, a good test of your ability to work with fractions, as well as your ability to perform long division. All right, so that's that one. All right, number 5 says, order the following values from least to greatest. We have 3/8, 1 5/8, 75%, 0.33, and negative 1/8. So right off the bat, I'm going to try to order these without doing any math whatsoever. And it should be pretty obvious that all of these numbers are positive, excluding this negative 1/8. So this negative 1/8 is going to be our smallest value. So we'll go ahead and put that first in our order since we're going from least to greatest. Let me go ahead and cross it out. And likewise, we should be able to tell that whereas all of our values are less than 1, 1 5/8 is bigger than 1. So that's going to be our largest value. So I'm going to put that at the big end of this ordering, and I'm going to cross it out as well. Now we have to determine the order of 3/8, 75%, and 0.33. Now, one way to compare these is to write them all in decimal form so we can quickly decide the order of them. And 0.33 is already in decimal form, so we're not going to have to do anything there. To write 75% in decimal form, all you do is take 75 and you take its decimal and you shift it 2 times to the left. So 75 in decimal form is 0.75. Okay, so finally we have to deal with this 3/8, and we can convert this to a decimal very quickly by doing some simple long division here. Again, 3/8 is the same as 3 divided by 8. And right off the bat, we ask ourselves, how many times does 8 go into 3? It doesn't, so I have to add a decimal here and a 0 placeholder. And likewise, I have to bring that decimal up right here. Now the question is, how many times does 8 go into 30 without going over? It's going to be 3 times, given that 8 times 3 is 24. 30 minus 24 is 6. And again, there's another 0 placeholder that we can bring down right here. And the question becomes, how many times does 8 go into 60? Well, 8 times 8 is 64, which is too big, so this is going to be 8 times 7, which will be 56. Okay, so approximately, and I'm not going to work this out fully because I already have enough information to answer this one. 3/8 is approximately 0.37. This is 0.75, and this is 0.33. Okay, so of all of those, 0.33 is the smallest, so we'll do 0.33 next. And then we have 3/8, which is 0.37. I think it's 0.375 if you keep working that out. So we're going to do 3/8 next. And then next to last, we'll do 75%. So this is the order we're looking for. -1/8. This one starts with 1 5/8, so that's out of order. Okay. 0.33 next. This one has 3/8 next, so it's not correct. Then we have 3/8, 75%, 1 5/8. So the answer to this one is going to be C. Okay, so that's that one. All right, number 6 says solve the following system of equations. We have 3.5x plus 2.5y equals 17, and negative 1.5x minus 7.5y equals negative 33. To start this one, I'm simply going to copy down the system of equations that we have. We have 3.5x plus 2.5y equals 17. Then we have negative 1.5x minus 7.5y equals negative 33. All right, so as far as system of equations go, there are multiple ways to solve them. You can either take your answer choices and plug them in for x and y. That's called the PiCAT method, or plug in the answers. In this case, I threw in decimals here to prevent people from doing that. If you plug in x and y with these decimals, you're going to have to do a lot of work and you're going to waste a lot of your time. But that said, the other two methods are the elimination and substitution method. In this case, we're going to use the elimination method, and that says multiply one of the equations by a constant such that when you add the two equations together, one of the variables is eliminated. So I'm going to take this top equation and I'm going to multiply it by 3. And in doing so, you're going to see that I'm going to be able to get rid of this y variable pretty easily. So again, I'm going to take this 3 and distribute it here, here, and here. So let's go ahead and work on doing that. I'm going to do this off to the side so as not to make any mistakes. We have 3.5 times 3 to start. Again, we're multiplying a decimal by a whole number. So to proceed, we want to shift this decimal one time to the right to make this 35 times 3, albeit with one decimal to shift back into the left at the end when we're done. 5 times 3 is going to be 15, carry a 1. 3 times 3 is 9 plus 1 is 10. Shift our one decimal back into the left. So this is 10.5x. Now, here's where you have to be able to do some mental math to figure out how to eliminate the y variable. 3 times 2 is 6. 3 times 0.5, well, that's 0.5, 1, 1.5. 6 plus 1.5 is 7.5. Okay, so 3 times 2.5 is going to be, and this is x, plus 7.5 y. And again, a lot of people can't do mental math that well, which means they would be lost as to how to eliminate one of these variables. Again, 3 times 2.5y is 7.5y. You have to be able to do that math, and it's not that hard to do to get this one set up correctly. And then we have 17 times 3, and I'm going to do that off to the side so as not to make any mistakes. 7 times 3 is 21, so bring down a 1, carry a 2. 1 times 3 is 3, plus 2 is 5, so this is 51 here. And we're just going to copy this one down as is. We have negative 1.5x minus 7.5y equals negative 33. All right, and again, now we're going to add these two equations together, right off the bat, we can see that plus 7.5y minus 7.5y is eliminated. Now we have 10.5x minus 1.5x. Again, this is going to be x. This 0.5 minus 0.5 goes away. This becomes 10 minus 1, which is 9. So this is 9x equals 51 minus 33. Well, let's work that out. 1 minus 3 we can't do, so we're going to have to borrow. This becomes 4. This becomes 11. 11 minus 3 is going to be 8, 9, 10, 11. So this is 8. And then 4 minus 3 is 1. All right, now we're just solving for x at this point, so we're going to divide both sides by 9 to get x by itself. This crosses out, leaving you with x equals 18 over 9, which is 2. Okay? All right, so to finish this system of equations, we take our value for x, plug it into one of the original equations, and then solve accordingly. Again, our original equations are 3.5x plus 2.5y equals 17, and negative 1.5x minus 7.5y equals negative 33. Since I don't like working with negatives, I'm going to plug this x value into this top equation. So we have 3.5x plus 2.5y equals 17. We now know what x is. X is 2, so this becomes 3.5 times 2 plus 2.5y equals 17. We should be able to do this mentally as well. 2 times 3 is 6. 0.5 times 2 is 1. So this is 7 plus 2.5y equals 17. Let's subtract 7 from both sides as our next step. This crosses out here, leaving you with just 2.5y on this side. 17 minus 7 is 10. Okay, so our goal is to solve for y at this point. So we're going to divide both sides by 2.5. This crosses out here, leaving you with y equals 10 divided by 2.5. You should be able to do this one mentally as well. 4 times 2 would be 8. 0.5 times 4 would be 2. 8 plus 2 is 10, so we know this is going to be 4. So we know our answer is x equals 2, y equals 4. Or if we write that as an ordered pair, it's going to be 2, 4. Again, x comes before y in ordered pair. So this one is 2, 4, which is answer choice B. Again, don't let those decimals intimidate you. When you have 0.5 as a decimal, it's not that hard to deal with. All right, so that's that one. All right, number 7 says, write the equation of a line that passes through the point 0, 1 and is perpendicular to y equals 5x. So first I want to point out that we're dealing with equations of lines. And more often than not, those are expressed like this: y equals mx plus b, where m refers to your slope and b refers to your y-intercept, which is the point at which the line touches the y-axis. Okay, so we're given this equation right here, this equation of a line right here, y equals 5x. We can see there's no y-intercept. That said, we have to use information about the slope of this line to figure out what the slope of our line is going to be. Okay, and we're told, what's more, that our line is perpendicular to this line. Well, you should know that parallel lines have the same slope, whereas the slopes of perpendicular lines are negative reciprocals of one another. So the slope of this line right here is right here. It's m equals 5. To find the slope of our line, we have to find the negative reciprocal of this line, which is 5, the slope of this line. So the negative reciprocal of 5, well, we know it's going to be negative. How can I write this such that I can find its reciprocal? Well, I can place this over 1. Again, 5 divided by 1 is just 5. The reciprocal of 5 over 1 is 1 over 5. So the slope of our line is going to be negative 1/5. Okay? Likewise, we're given the point 0, 1, and we now know our slope is negative 1/5. Using these two pieces of information, we can write the equation of our line pretty easily. Again, we're just going to plug these values into the point slope equation, which is this: y minus y1 equals m times x minus x1. This x1 and y1 are the values of your ordered pair, so this is going to be our x1 and our y1, and m, as we can see, is negative 1/5. So let's just plug these things in and simplify accordingly. This is y minus y1 is just 1, as you can see right there, equals m. M is negative 1/5 times x minus x1. X1 is 0. Okay, so let's start simplifying. Again, I'm going to take this negative 1/5 and distribute it here as well as here as my next step. So this is y minus 1 equals negative 1/5 times x is negative 1/5 x. Negative 1/5 times 0 is just 0, so we're not going to express that. Now we're just going to add this 1 to both sides, and this crosses out here, leaving us with y equals negative 1/5 x plus 1. Just like that, we wrote the equation of our line. It is y equals negative 1/5 x plus 1, which we can see is a. Again, parallel lines have the same slope, whereas perpendicular lines have slopes that are the negative reciprocals of one another. You have to know that for the ASVAB. You might see a question involving parallel lines, and you might see a question involving perpendicular lines. Either way, you should be able to write an equation of a line given these things. Okay, so that's that one. All right, number 8 says completely factor. We have 4x cubed plus 2x squared minus 2x minus 1. So again, we have 4x cubed plus 2x squared minus 2x minus 1. Now you might be saying to yourself, well, how do I factor this? We got a cube here. I don't know how to factor cubes. Well, this one is a little challenging insofar as it's testing your ability to realize that you can factor this one by grouping. And what I like to do when I'm factoring by grouping is I like to imagine that right in the middle of this equation, we split them up. Okay, so I'm only going to focus on this 4x cubed plus 2x squared, and then I'm going to focus on this negative 2x minus 1 next. Okay, so again, let's just focus on these first two terms. What can I factor from 4x cubed and 2x squared? Well, I can factor out a 2x squared. This will become 2x plus 1 over here. Okay? Now that I've factored these first two terms, I want to factor this second pair of terms such that I get the same thing in parentheses. And how can I do that? Well, if I factor out a negative 1 over here, this becomes 2x plus 1. Okay? And now, if you remember how to factor by grouping, we combine these numbers outside the parentheses as one set of solutions, so that's going to be 2x squared minus 1. And then we just copy down one of these that's repeated, so this is 2x plus 1. And just like that, we factored this one by grouping. And let's see what answer choice this is. We have 2x squared minus 1 right here, and 2x plus 1 right here. Okay, so that's that one. Again, we just had a factor by grouping to solve this one. On my channel, I have 3 or 4 videos in regard to the factoring techniques you need to know for the ASVAB, including how to factor by grouping. I think in each of those videos, I try to do 30 practice problems. So if you don't know how to factor by grouping, go ahead and check that video out. There, I show you exactly how you can do these problems pretty quickly. All right, so there's that one. All right, number 9 says the diameter of a circle is 28 centimeters. What is the area of the circle? For pi, use 22 over 7 to approximate your answer. Okay, so for this one, let's draw a circle to see what's going on here. Again, we know the diameter of this circle is 28 centimeters according to the problem. Well, diameter is defined as the distance from one edge of the circle to the other edge of the circle and through the center point of the circle. So that distance I drew right there, notably from here to here, is 28 centimeters. Okay. What's more, we have to know the formula to find the area of a circle. That's area equals pi r squared, where r refers to the radius. The definition of a radius is the distance from the center point of the circle to the edge of the circle. And the radius is always diameter over 2. That is to say, the radius is always half as long as the diameter. So the radius in this case is going to be 28 over 2. And this should be pretty easy to figure out. 8 divided by 2 is 4. 2 divided by 2 is 1. So our radius in this case is 14. So let's go ahead and start plugging these values in to this formula here. We have area equals pi 14 squared. And again, we're told to use 22 over 7 to approximate pi. So this becomes area equals 22 over 7 times 14 squared. Again, if you remember the order of operations, we're going to do exponents before multiplication. And so as not to make any mistakes, I'm going to do 14 times 14 off to the side here. You should know what the answer to this is without having to work it out. Again, on the reference sheet on my website, I do mention all the squares you should try to remember for the ASVAB. This is one of them. But that said, let's work it out. We have 4 times 4, which is 16. So we're going to drop down a 6 and carry a 1. Then we have 1 times 4 plus 1, which is going to be 5. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 6 plus 0 is 6. 5 plus 4 is 9. 1 plus nothing is 1. So this is area equals 22 over 7 times 196. Okay? All right, so one thing we can do to make this a little bit easier is to try to reduce this 196 and this 7. Again, technically this is 196 over 1 times 22 over 7, which means I can simply say 7 goes into 7 one time, and if 7 goes into 196 evenly, we can deal with that accordingly. So let's see if it does. 196 divided by 7. 7 goes into 19 2 times without going over. Given that 2 times 7 is 14. 19 minus 14 is 5. Drop down this 6. 7 goes into 56 8 times without going over. 7 times 6 is, or 7 times 8 is 56. So we can see there's no remainder. So this becomes 28 here. So this becomes 22 over 1 times 28 over 1. Again, anything divided by 1 is itself. So this is 22 times 28, which isn't that hard to do, but we're going to work it off to the side so as not to make any mistakes. So this becomes 28 times 22. 8 times 2 is 16. Carry a 1. 2 times 2 is 4 plus 1 is 5. Before we start multiplication with this 0, this 2, we have to bring in a 0 placeholder. 2 times 8 is 16. Carry a 1. 2 times 2 is 4 plus 1 is 5. Let's add these together. 6 plus 0 is 6. 5 plus 1 is 11. Carry a 1. 5 plus 1 is 6. So this is 616 centimeters squared for the area of this circle, which is answer choice D. All right, so that's that one. All right, number 10 says, a flagpole cast a shadow of 25 feet. Nearby, a 6-foot tree cast a shadow of 3 feet. What is the height of the flagpole? So for this one, it's going to be helpful to draw a diagram to figure out what's going on here. Again, we have a flagpole, which has an unknown height, so I'm going to call that X, that cast a 25-foot shadow according to this problem. So that's going to be 25 feet right there. And nearby, we have a 6-foot tall tree that's casting a shadow of 3 feet. Okay? If I enclose these shapes, you should see that they're both right triangles, which means that we can regard these figures, these triangles, as similar figures. And as far as similar figures go, you can use a proportion to solve any missing value. So again, I'm going to take this x and place it over 25 in this left-hand side of my proportion. And I'm going to take this 6 and place it over this 3. By cross multiplying, I'll be able to solve for x pretty quickly. So this becomes 3 times x, which is 3x, and then 6 times 25, which is 6 times 25. I'm going to write that out before we work it out. So this is 3x. 6 times 25. Of course, you could do 25 times 6 like this off to the side and figure that out. But again, when you're doing the ASVAB, you have to use mental math where appropriate. 25 times 4 is 100, plus 25 is 125, plus 25 one more time is 150. So 6 times 25 is 150. Again, we're solving for x at this point, so we're going to divide both sides by 3. This crosses out here. This says x equals 150 divided by 3. Likewise, that should be pretty easy to do. 15 divided by 3 is 5, and just bring down that 0 there. So this is x equals 50, which means that this flagpole is 50 feet tall, which is C. Okay, so again, on the ASVAB, in order to be very successful, you're going to have to be able to do mental math where appropriate. Otherwise, you're going to get bogged down with, simple arithmetic like this, and this takes up time. Again, 150 divided by 3 is 50. That should be pretty easy to do. All right, so that's that one. Number 11 says, find the mean, median, and range of the following. We have 10.4, 2.4, 23.6, 38.2, 23.8, and 21.6. So whenever I'm asked to find the mean, median, and range, the very first thing I'm going to do is order these numbers from least to greatest. So we have 2.4, that's the smallest. I'm going to mark them as I do them. Next we have 10.4, so this is 10.4. Then we have 23.6. Oops, I take that back. We have 21.6. Then 23.6. And then 23.8. And finally 38.2. The easiest thing to figure out once you order these from least to greatest is the range. So let's go ahead and do that. The range is always the biggest value minus the smallest value. Since we ordered these from least to greatest, we know this is our biggest value, this is our smallest value. So the range is, in this case, is going to be 38.2 minus 2.4. Let's go ahead and work that out. 2 minus 4 we can't do, so we have to borrow. This becomes 7. This becomes 12. 12 minus 4 is going to be 8, 9, 10, 11, 12. This is going to be 8. Drop down your decimal in place. 7 minus 2 is 5, and 3 minus nothing is 3. So the range for this one is 35.8. Let's see if all of them have a range of 35.8. They all do, so we can't eliminate any of these answer choices yet. The next easiest thing to figure out is the median. Again, you find the median by crossing off values at each end until you get to the middle term or the middle two terms. If there are an even number of terms, your median's always going to be the average of the two middle terms. So let's start crossing these off. We have one here, one here, one here, and one here. Again, since there were 6 terms in this data set, we know the median is going to be found by taking the average of these two. So that's going to look like this: 21.6 plus 23.6 divided by 2. And let's work this off to the side so as not to make any mistakes. We have 21.6 plus 23.6. 0.6 and 0.6 is, our 6 and 6 is 12. So we're going to carry a 1 here, drop down our decimal. 1 plus 3 is 4, plus 1 is 5. 2 plus 2 is 4. So this becomes 45.2 over 2. And again, that's the same as long division. So let's go ahead and work that out. That's 45.2 divided by 2. Bring up your decimal right here before you begin. 2 goes into 4 2 times without going over. 2 times 2 is 4, so subtract 4 there. 4 minus 4 is 0. Drop down this 5. 2 goes into 5 2 times without going over. 2 times 2 is 4, so we're going to subtract 4 here. 5 minus 4 is 1, and we bring down this 2 now. 2 goes into 12 6 times without going over. 2 times 6 is 12, so there's no remainder. In other words, the median here, let me write that over here, the median is going to be 22.6. Okay? All right, let's see if that will allow us to eliminate any of our answer choices here. This has a median of 22.4, so we know that's not correct. The median here is 22.6, 22.6, 22.6. So it looks as if we're going to have to find the mean now. So in order to find the mean, we're going to sum all the numbers and divide by how many numbers there are. So that's going to look like this: 2.4 plus 10.4 plus 21.6 plus 23.6 plus 23.8 plus 38.2. Let's divide by how many numbers there are. There are 1, 2, 3, 4, 5, 6 of these. Okay, so as not to make any mistakes, I'm going to add these vertically, and I'm going to add them like this. We have 38.2, 23.8, 23.6, 21.6, 10.4, and 2. Let me put that in the right place, 2.4. If you want to, you can go ahead and drop down your decimal in place. And let's go ahead and get started doing this. We have 6 plus 4, which is 10, 6 plus 4, which is 10, and 2 plus 8, which is 10. So this is 10, 20, 30. So we're going to drop down to 0 and carry 3. Let's keep working this out. We have 2 plus 1, which is 3, plus 3, which is 6, plus 3, which is 9, 10, 11, 12. 12 plus 8 is 20, so this is 0. Bring down our carry a 2. And let's do this last bit here. We have 2, 4, 6, 8, 9, 10, 11, 12. So this is 12. So this becomes 120 divided by 6. And again, this should be pretty easy to do mentally. 12 divided by 6 is 2, and then just tack on that 0. So the mean in this case is 20. So we're looking for these values. We're looking for 20. The median was 22.6, and the range was 35.8. So we're looking for these values right here. That is 20, 22.6, and 35.8. That's going to be B. All right, so that's that one. A lot of people struggle with decimals and fractions, but that said, I included them in this video heavily so as to really force you to deal with them. Again, they may show up on the ASVAB, so you want to be comfortable working with them. You don't want to say, oh, there's decimals, I can't do it. Again, work your way through them. It's not as bad as you think. All right, number 12 says, if angles of measures x minus 2 and 2x plus 5 degrees are a pair of complementary angles, find the measures of those angles. Okay, so for this, we have to know the definition of complementary angles. Complementary angles are two angles that add up to 90 degrees, okay? And again, I wrote that out for you. For angles to be complementary, they have to add up to 90 degrees, which you can see right here. So let's call this angle 1, let's call this angle 2. And instead of just having the angle symbol in 1 and 2 here, we can replace them with the variable. So this could be x minus 2 plus 2x plus 5 equals 90 degrees. Now we're just solving for x at this point. So let's combine our like terms. We have x and 2x, which is 3x. Negative 2 and positive 5, that's going to be plus 3 equals 90. Again, we're solving for x, so we want to get x by itself. Let's subtract 3 from both sides. This leaves you with 3x over here. 90 minus 3 is going to be 90, 89, 88, 87. Divide both sides by 3 as our next step to get x by itself finally. So this says x equals 87 over 3. And as you should know by now, this is the same as 87 divided by 3. There's a quick check to tell if this is going to work out evenly. 8 plus 7 is 15. 15 is divisible by 3 evenly. Therefore, I know 87 is going to be divisible by 3 evenly. So this becomes, how many times does 3 go into 8 without going over? That's going to be 2 times, given that 2 times 3 is 6. 8 minus 6 is 2. Drop down this 7. 3 goes into 27. 9 times without going over. 9 times 3 is 27. So we can see there's no remainder. So we know x is 29. That said, we want to know what the measure of these two angles are. And as we should see, this first angle corresponded with x minus 2. This second angle corresponded with 2x plus 5. So again, let's write that out. Angle 1 corresponded to x minus 2. We now know x is 29. So all we do is have to plug in 29 where we see x. So this says angle 1 equals 29 minus 2. Angle 1 equals 29 minus 2 is going to be 27. Okay, so that's that one. Angle 2 said it was 2x plus 5. Again, we know x is 29. So in place of x, let's put 29 now. This is angle 2 equals 2 times 29 plus 5. Again, I'm going to work this off to the side so as not to make any mistakes here. This is 29 times 2. 9 times 2 is 18, so drop down an 8, carry a 1. 2 times 2 is 4, plus 1 is 5. So this becomes angle 2 equals 58 plus 5. Angle 2 equals 58, 59, 60, 61, 62, 63. So the measure of our two angles are 27 and 63 degrees respectively, which we can see is answer choice B. Okay, so that's that one. Not too difficult, but again, for the ASVAB, you have to know the definition of complementary and supplementary angles. Complementary angles is a set of two angles that add to 90 degrees, whereas supplementary angles are a pair of two angles that add to 180 degrees. Okay, and I do have videos on that on my channel if you need to review that. All right, number 13 says, what three terms come next in the sequence? We have 0.5, 2.0, 4.5, 8.0, 12.5, blank, blank, blank. So the key to these is to kind of look at the numbers until you discover the pattern that gets you from term to term in the sequence. So that said, I'm thinking right now, what number is going to take me from the first term, 0.5, to the second term, 2.0? Well, I know 0.5 plus 1.5 will give me 2. So that works for the first one. Let's see what happens in the second one. What's going to take me from 2.0 to 4.5? Well, I know plus 2.5 will get me there. Again, 2.0 plus 2.5 is 4.5. All right, let's see what's going on from this third term to this fourth term. I know 4.5 plus 3.5 will get me to 8. Again, 4.5 plus 3.5 is 8. What's going to get me from 8 to 12.5? That's going to be plus 4.5. So we can see our pattern here. We're just increasing by 1 from 1.5. So to get from 12.5 to this first unknown term, we're going to add 5.5. Okay, so in case you can't do that mentally, we can work it off to the side like this. 12.5 plus 5.5. Again, drop down your decimal if you want to start. 5 plus 5 is 10, so bring down a 0 and carry a 1. 5 plus 2 is 7, plus 1 is 8, and just drop down your 1. So this next term is going to be 18. And if we look through our answer choices, we can see that only one of them starts with 18. So this is more than likely going to be the correct answer. But let's keep working this one out just to confirm that. To get from this 18 to this next term, we're going to add 6.5. So this becomes 18 plus 6.5. 0 plus 5 is 5. Drop down your decimal. 8 plus 6 is 14. Carry your 1. 1 plus 1 is 2. So our next term is 24.5. And to go from 24.5 to our next term, we're going to add 7.5 now. And I'm not going to do this one since I can do it mentally. 7.5 plus 24.5 is in fact 32. Okay, so that's that one. Again, don't let these decimals defeat you, and don't let fractions defeat you. You will see them on the ASVAB. You might not see them this often, but I put them in this practice test to see if you would just give up. And again, you don't want to be defeated by something as simple as these decimals. All right, number 14 says simplify the expression. We have 15a to the fifth, b squared, c to the fourth, over 25a to the third, b to the third, c to the fourth. So I'm going to start by copying this one down. Again, we have 15a to the fifth, b squared, c to the fourth, all over 25a to the third, b to the third, c to the fourth. Okay, so in order to do this one, we're going to have to know our laws of exponents. Specifically, we're going to have to know our quotient rule. Quotient rule says this: if you have a to the m over a to the n, that's the same as a to the m minus n. And that's what we have in this case. So as we work this one out, let's be mindful of this law of exponent over here. But that said, the very first thing we're dealing with is this 15 and 25. We're trying to reduce it. And you should see that both 15 as well as 25 are divisible by 5. So let's reduce that to be this. 15 divided by 5 is 3. 25 divided by 5 is 5. So we went ahead and took care of those whole numbers right there. This a to the fifth over a to the third, we can use the quotient rule to reduce that. Again, if I pull this out to the side, this is a to the fifth over a to the third. And if we look at our law of exponent here, we can see that this says to subtract our exponents. So this becomes a to the 5 minus 3. 5 minus 3, of course, is 2. So this is a squared here. We just took care of those. This one says b squared over b to the third. So again, we're going to use the quotient rule to subtract our exponents. So this becomes b 2 minus 3. 2 minus 3 is negative 1. So we couldn't write it as b to the negative 1. Instead, this becomes 1 over b to the 1. Okay? Again, you can't leave exponents negative. Instead, you place them either in the denominator or numerator. and with a positive exponent instead. So this is 1 over b to the 1, which means we can stick it right here. And since its exponent is 1, I don't have to express that 1 over here, okay? And finally, we have c to the 4th over c to the 4th. Again, we took care of these right here. This is the same, according to the quotient rule, as c to the 4 minus 4, which is c to the 0. Anything raised to the 0 power is 1. So you can have a million. Let's do 1,000 to the 0 power. That's going to be 1. C to the 0 power is going to be 1. And anything times 1 is itself, so we don't have to express that here. So simplified, this is just 3a squared over 5b, which we can see as answer choice D in this case. Okay, so that's that one. Again, I do have a video on the laws of exponents. At first glance, they can be challenging, but once you learn those laws of exponents, you should be set for the ASVAB. So check out that video if you need to. All right, number 15 says simplify the expression. We have 2 square root 18 minus 5 square root 32 plus 7 square root 162. All right, so for this one, it should be obvious that we're going to have to simplify these radicals in order to simplify the expression. So not surprisingly, I'm going to start by copying this down. We have 2 square root 18 minus 5 square root 32 plus 7 square root 162. I'm going to do these one at a time in case you haven't seen how this is done in a long time. So let's start with this 2 square root 18. Let's rewrite this to be 2 times the square root of 9 times 2. Again, 9 times 2 is the same as 18. And if you know our laws of radicals, we can break this down even further to be 2 times the square root of 9 times the square root of 2. Well, the square root of 9 is 3, so this becomes 2 times 3 times the square root of 2. 2 times 3 is 6, so this is 6 square root 2. And just like that, we simplify this 2 square root 18 to be 6 square root 2. Okay? Let's do the same thing for this negative 5 square root 32. Again, I'm just going to hold this negative off to the side and just deal with this 5 square root 32 separately. I know 32 is the same as 16 times 2. Okay? And if we know our laws of radicals, this becomes negative 5 times the square root of 16 times the square root of 2. Again, I just broke those apart. Negative 5. The square root of 16 is 4 times the square root of 2. Negative 5 times positive 4 is negative 20. Of course, this is square root 2. Okay, so we just took care of this negative 5 square root 32. Let's do the same thing with this plus 7 square root 162. Again, I'm going to just pull out that plus right here. This is 7, and 162 is not that easy to do. So let's think about what we're going to do here. We're going to use some prime factorization to figure out what these factors are. What times 2 would be 162? Well, 16 divided by 2 is 8, and 2 divided by 2 is 1. So this becomes 7 times the square root of 81 times 2. If we know our laws of radicals, this becomes 7 times the square root of 81 times the square root of 2. This becomes 7. Square root of 81 we should know is 9 times the square root of 2. 7 times 9, of course, is 63, so this is plus 63. And my pen's starting to act up there. Square root 2. Okay, so we put these radicals in simplest terms, and now we could just add them. And this isn't that difficult to do. 63 plus 6 is going to be 69, so this becomes, and I'm running out of space, so I'm going to move over here. This becomes 69 square root 2 minus 20 square root 2. Again, I just took this 6 square root 2 and added it to this 63 square root 2. And 69 minus 20 is going to be 49 square root 2. So the answer to this one is 49 square root 2, which is answer choice C in this case. Okay, so that's that one. All right, for this last one, it says simplify the expression. We have x squared plus 4x plus 4 over x minus 3 all over 3x plus 6 over 5. So let's start by copying this one down. And I'm going to do that. Let's see where I have more space at. I have more space over here, so let's do it over here. We have x squared plus 4x plus 4 over x minus 3 all over 3x plus 6 over 5. All right, so this is the division of two algebraic fractions. We have one fraction here and one fraction here. And what do we know about the division of fractions? We perform that by following the algorithm keep, change, flip. So we're going to keep this top fraction the same. So that's going to be x squared plus 4x plus 4 over x minus 3. We kept that top fraction the same. We're going to change this sign from division, which this is the division bar right here, to multiplication. So that's the change. And then we're going to flip this second fraction. So instead of being 3x plus 6 over 5, it's going to be 5 over 3x plus 6. Okay, and that's our flip. And now you might be saying to yourself, well, how do I multiply these fractions? I got this x squared plus 4x plus 4 in the numerator over here. Can I multiply that by 5? Well, before we do this multiplication, let's go ahead and simplify what we can. You should realize that we can factor this, and it's going to look like this: x times x. And now we're looking for two factors that multiply to 4 and add to 4, so that's going to be plus 2 plus 2. Again, x minus 3 we can't simplify, so we're not going to do anything with that. Then we're going to multiply by 5. Can't simplify that. But what about this 3x plus 6? I can pull out a 3 here, which will leave me with x plus 2. Okay, so this becomes 3 times x plus 2. Before I multiply now, I can cross out an x plus 2 here and an x plus 2 here. Okay, now that I've done that, let's just multiply straight across as we normally would when we work with fractions. So this becomes 5x plus 2 over 3 x minus 3. And we can't simplify this one any further, so this is our answer right here. And let's look for it over here. Again, that's 5x plus 2 over 3x minus 3. And that is going to be answer choice A. Okay, so that's that one. Again, this is a set of algebraic fractions. You follow the rules of fractions as well as algebra. When you divide fractions, you follow the algorithm keep, change, flip. And when you have a quadratic like this, it's always a good idea to try to simplify it by factoring. Okay, so that's that one. All right, so before I end today's video, I want to make an announcement regarding a new feature you're going to see on my channel. Next to my subscribe button, you're going to see a join button now, and that's going to enable you to become a member of my Hero Club. When you do that, you're going to get custom loyalty badges as well as emojis that will display in the comment section of my videos. And in addition to those two things, I'm also going to start posting learning materials to supplement my videos, exclusive members-only videos, and responses to any of your questions. So if you want to support my channel and help it keep growing, please consider becoming a member of my Hero Club. Costs $1.99 a month, and you can cancel at any time. Regardless of whether you become a member or not, I'm still going to be posting a lot of free content on my channel. So Again, this is just another way for you to support my channel. But on that note, let's go ahead and wrap this video up. I hope you found this practice test helpful. As you might expect, I included a lot of decimals and fractions in this one to challenge you a little bit. In my personal opinion, I'd rather you struggle with a practice test than on the real test. So I hope you found that aspect of this practice test helpful. As always, you're more than welcome to leave feedback in the comments section below. And on that note, I'm going to go ahead and cut you loose.